So our goals: derive the laws of radicals and simplify radical expressions using the laws of radicals. A radical is in its simplest form when 1. There is no perfect n power in the radicand when the index is n. Number 2, the index is the lowest possible index. And number 3, a radical is also in its simplest form when there is no radical in the denominator or a fraction in the radicand. So, anong ginagawa natin kapag may nakita tayong ganyan? We rationalize the denominator. And that is the focus of our discussion today. Simplifying radicals by rationalizing the denominator. In a radical expression, if there is a radical number in the denominator, the expression is not in the simplest form. The process of eliminating the radicals in the denominator of the expression is called rationalization. To rationalize the denominator, you have to multiply that fraction by a number such that the resulting radicand in the denominator is a perfect nth power. Para mas mabilis natin maunawaan ang tinutukoy ng statement na ito, let us have the following examples. Suppose we have 1 over the square root of 3. At dahil radical ang kanyang denominator, kailangan natin na i-rationalize ang fraction na ito. So, paanong paraan? Yung statement natin kanina. Multiply the denominator and the numerator by a number such that the resulting radicand in the denominator is a perfect nth power. So, saan natin ito i-multiply? Tignan ang denominator. We have the square root of 3. Kaya, i-multiply natin ang numerator at denominator sa square root of 3. So, we have sa numerator, 1 times the square root of 3, which is equal to square root of 3. At sa denominator naman, square root of 3 times the square root of 3 is equal to the square root of 3 squared, or simply square root of 9. Hindi ko na siya ipinakitang 9 para ma-visualize nyo kung paano ito magiging perfect nth power. At this point, alam naman natin na kapag equal ang index at exponent ng radicand, pwede natin itong makancel. So, simplifying this further, we have square root of 3 over 3. And this is the simplest form kasi wala na tayong radical sa denominator. Isa pang example. We have 1 over the cube root of 3. Pansinin nyo yung pattern, ha? So, in this term, imumultiply natin ang numerator at denominator dito sa factors na ito. So, we have sa numerator, 1 times the cube root of 3 times 3, which is equal to the cube root of 9. At sa denominator naman, the cube root of 3 times the cube root of 3 times 3, which is equal to the cube root of 3 cubed. Hindi ko na uli ito ipinakitang ni-raise ko sa power para ma-visualize nyo kung paano ito magiging perfect nth power. So, at this point, alam naman natin sa denominator na kapag equal ang index at exponent ng radicand, pwede na natin itong makancel. So, simplifying this further, we have the cube root of 9 all over 3. And this is the term's simplest form kasi wala na tayong radical sa denominator. Isa pang example. We have 1 all over the 4th root of 3. Tulad ng ginawa natin kanina, i-multiply lang Sa numerator, 1 times the 4th root of 3 times 3 times 3, which is equal to the 4th root of 27. At sa denominator naman, the 4th root of 3 times the 4th root of 3 times 3 times 3, which is equal to the 4th root of 3 raised to the 4th power. Hindi ko na uli ito ipinakitang ni-raise ko sa power para ma-visualize nyo kung paano ito magiging perfect nth power. At this point, alam na natin kapag equal ang index at exponent ng radicand, pwede na natin itong makancel. So, simplifying this further, we have the 4th root of 27 all over 3. And this is the simplest form kasi wala na tayong radical sa denominator. Isa pang example, we have 1 all over the 5th root of 3. Tulad ng ginawa natin kanina, i-multiply lang. Sa numerator, 1 times the 5th root of 3 times 3 times 3 times 3, which is equal to the 5th root of 81. At sa denominator naman, the 5th root of 3 times the 5th root of 3 times 3 times 3 times 3, which is equal to the 5th root of 3 raised to the 5th power. So, simplifying this further, we have the 5th root of 81 all over 3. And this is the simplest form kasi wala na tayong radical sa denominator. Isa pang example. We have 1 over the 6th root of 3. Tulad ng ginawa natin kanina, i-multiply lang. Sa numerator, 1 times the 6th root of 3 times 3 times 3 times 3 times 3, which is equal to the 6th root of 243. At sa denominator naman, the 6th root of 3 times the 6th root of 3 times 3 times 3 times 3 times 3, which is equal to the 6th root of 3 raised to the 6th power. So, simplifying this further, we have the 6th root of 243 all over 3. And this is its simplest form kasi wala na tayong radical sa denominator. Ayan, gets nyo na paano malalaman yung factor na i-multiply para ma-rationalize ang denominator. So, let us solve some problems. Problem 1. Simplify the square root of 3/5. Express as quotients of two radicals. So, pinaghiwalay lang. Then, multiply the numerator and the denominator by the least radical, which will make the radicand in the denominator a perfect square. Ito yung ginawa natin kanina. So, saan i-multiply ang numerator at denominator? Sa square root of 5 para maging perfect nth power yung denominator natin. Kaya naman, we have the square root of 15 over the square root of 25. Now, the denominator is a perfect square. Simplify, therefore, final answer is the square root of 15 over 5. Problem 2. Simplify the cube root of 3/2. Express as quotients of two radicals. So, pinaghiwalay lang. Then, yung ginawa natin kanina, rationalize. Saan i-multiply ang numerator at denominator? Sa cube root of 2 times 2. Para maging perfect nth power yung denominator natin. Kaya naman, we have the cube root of 12 over the cube root of 8. Now, the denominator is a perfect cube. Next, simplify. Therefore, final answer is the cube root of 12 all over 2. Problem 3. Simplify the cube root of 2 over a squared. Express as quotients of two radicals. So, pinaghiwalay lang. Then, yung ginawa natin kanina, rationalize. Pero, pansinin nyo ito, we have a squared as radical at ang ating index ay 3. So, para maging perfect nth power ito, isang a na lang ang kailangan natin. So, saan i-multiply ang numerator at denominator? Sa cube root of a para maging perfect nth power yung denominator natin na cube root of a squared. Kaya naman, we have the cube root of 2a over the cube root of a cube. Now, the denominator is a perfect cube. Simplify. Therefore, the final answer is the cube root of 2a all over a. Madali lang, di ba? But, just in case, what if a binomial with a radical term is present in the denominator? How can we rationalize it? Ang sagot, conjugates. So, ano ang conjugates? Conjugates are extremely helpful when we want to rationalize radical expressions. Two binomials are conjugates when they have the same terms but opposite signs in the middle. Ayan, parehong mga terms pero magkaiba ng sign sa gitna. Example, 3 plus the square root of 2. Ang conjugate ng term na ito ay 3 minus the square root of 2. Pareho ng mga terms pero magkaiba ng sign sa gitna. Another example, the square root of 5 minus the square root of 2. Ang conjugate ng term na ito ay the square root of 5 plus the square root of 2. Again, magkapareho ng mga terms pero magkaiba ng sign sa gitna. The product of the radical expression and its conjugate is an integer. Finding its product is the same procedure in multiplying the sum and difference of two binomials. Ayan, yung rule na nandoon sa yellow box natin. Naalala nyo ba yan? So, let us have some example. Let us find the product of the radical expression 3 plus the square root of 2 and its conjugate. So, multiplying the two binomials, sundan lang natin yung ating rule sa sum and difference of two binomials. Square the first term minus square the second term. And we have 3 squared is 9. The square of the square root of 2 is 2. Equal ang index at exponent. Cancel lang yan, di ba? Kaya naman, we have 9 minus 2. Which is equal to 7. O di ba? Nawala na uli yung binomial na may radical. Isa pang example. Let us determine the product of the radical expression square root of 5 minus the square root of 2 and its conjugate. So, multiplying the two binomials, sundan lang natin itong ating rule ulit sa sum and difference of two binomials. And we have the square of the square root of 5 is equal to 5. At ang square of the square root of 2 naman is equal to 2. Equal ang mga index at ang mga exponent. Kaya cancel lang, di ba? Kaya we have 5 minus 2. which is equal to 3. O, diba? Nawala na uli yung binomial na may radical at ganun lang mag-multiply ng terms at ng kanyang conjugate. Now, let us solve some problems. Rationalizing the denominator with conjugates. Rationalize the expression 3 all over 2 minus the square root of 3. Solution, find the conjugate of the denominator. Isulat lang natin yung given. Then, multiply the numerator and the denominator by the conjugate. Kaya, sa numerator, we have 3 times the quantity of 2 plus the square root of 3. At sa denominator naman, we have 2 squared minus the square root of 3 raised to the second power. Yung rule lang natin sa sum and difference of 2 binomials. Then, simplify the denominator. Kaya naman, we copy muna yung numerator, then yung denominator natin is 4 minus 3, which is equal to 1. Dahil 1 na lang ang ating denominator, there is no need to write it anymore. Kaya, ito yung numerator natin, and we will apply the distributive property para masimplify ito. So, we have 3 times 2, that is 6. Then, 3 times the square root of 3, that is 3 square root of 3. We cannot combine these two terms further kasi hindi sila similar terms. Therefore, ang final answer natin is 6 plus 3 square root of 3. And that is how we simplify radical expressions by rationalizing the denominator with conjugates. And that is our lesson for this week. See you again next time. Ingat and God bless.